Okay, so basically this question is from summer 15, paper 42. Question number 8. So the question says that NMR spectroscopy and X-ray crystallography, which is not part of the syllabus anymore. So we are only going to discuss the NMR part. They can both be used to examine the structure of organic compounds. Now, NMR is very useful at examining hydrogen atoms in compounds, but hydrogen atoms are invisible to X-rays. Explain why NMR spectroscopy can detect the hydrogen atoms in a molecule. So this is just 1 mark question. So because hydrogen atom has a spin associated to it, as it has only one proton present in the nucleus, so the nuclei with the odd number of nucleons, they have a spin associated with them, and when radiations falls on those nuclei, their spin changes and they jump from a lower energy level to a higher energy level. This is why they are detectable on a NMR spectrum. So what we would write here is that the hydrogen nucleus has a spin associated to it, which is detectable on proton NMR. Right, and why it has a spin? Because of the odd number of nucleons. It has only one proton. Okay, and then the next parts are from the X-rays, so we'll skip these parts. And now the graph. So the next part says the NMR spectrum below was obtained from an organic liquid P, which contained 5 carbon atoms per molecule. So 5 carbon atoms per molecule, and this is proton NMR, right, of this compound. How many protons are present in one molecule of P? Explain your answer. Number of protons. So this peak is due to 9 protons, this peak is due to 1 proton, and this peak is due to 2 protons. So in total we have 9 plus 1 plus 2. So this molecule P has a total 12 protons. Right, so 5 carbon atoms and 12 protons. Okay, then the next part says that when a little D2O is added to P, the absorption at 2.0, chemical shift 2.0 disappears. This one will be disappeared on adding D2O, right? So explain what this tells you about the group responsible for this absorption and why. So basically this is due to proton exchange. We have studied this thing that if a molecule has OH group present in it or NH2 group present in it, and if we add D2O, which is heavy water, which contains the heavier isotope of hydrogen, that is deuterium, deuterium will replace H from the OH, or it will replace H from the NH2, and this proton, due to this proton exchange, we get D instead of H, instead of protium, we get deuterium in the structure. And deuterium will not give any peak, or it is undetectable on a proton NMR, as it has odd number of nucleons, so its spin would be cancelled out. Right, so why this tells, what this tells you about the group responsible for this absorption and why. So that means this molecule P, because the peak at 2.0 disappears, that means molecule P has an OH group present, right, and due to proton exchange, the OH peak disappears. Right, so instead of OH now we have OD, so that's why that peak would be disappeared from the spectrum. Now why we have written here OH, why not NH2? If you look at the graph, they're saying they're telling us that this peak at 2.0, how many hydrogens are responsible for this peak? Only one hydrogen. right? So that means it would be OH, not NH2, right? So we have OH present in the molecule. Now, what does the absorption at chemical shift 0.9 tells you about the adjacent carbon atom, right? The peak at 0.9, what it tells us about the adjacent carbon atom. So the peak at 0.9, we all know this thing that the information that we can get from a peak about the adjacent carbon atom is that how many hydrogens it has. So because we have a singlet here at 0.9, right? So the pattern which we have is a singlet. So that means the neighboring carbon atom would have only would have no hydrogen atoms, right? Because the splitting pattern is the formula n plus 1, where n is the number of hydrogens on the neighboring carbon atom. So if n is 0, if there are no hydrogen atoms on the neighboring carbon atom, that means split pattern would be of 1, and that would be a singlet, right? So because we are getting a singlet, that means the neighboring carbon atom or the adjacent carbon atom has no hydrogen atom bonded to it. So that means the adjacent carbon has no hydrogens, right? What group is responsible for the absorption at 0.9? Group responsible for the absorption at 0.9. So for that, you have to look in the data booklet. So here's the data booklet, and you can see that this is 0.9, right? So that means CH3 or CH2 or an alkyl is responsible for the peak at 0.9. So the peak at 0.9 is due to CH3 group or a CH2 group, right? But because there are 9 hydrogen atoms, if you look at the graph, there are 9 hydrogen atoms, so that means it would be CH3. Now suggest a structure for P. Now what we know about P is that P has 5 carbon atoms, it has 12 hydrogen atoms, and it has an OH group present as well, right? So that means in total we have 5 carbons and 12 hydrogens and an oxygen atom. So if we draw the structure, now there are only 3 different types of protons. From the proton NMR, we get this information as well, that there are only 3 different types of protons, out of which 9 are same, and these 2 are same. And the other information which we are also getting is that this is also a singlet. This is also a singlet. That means the adjacent carbon to this proton has also no hydrogen atoms attached to it. And this peak is due to OH, right? So that means 3 of the carbon atoms have same type of protons, as you have 9 similar protons. So that means we have 3 CH3 group attached to the same carbon atom. So this would be the carbon atom, and CH3, CH3, CH3. So these are 9 protons attached to the same carbon atom. And if I attached one more carbon atoms to this carbon, so now it has no hydrogen atoms, and now you can say that these hydrogens would give a singlet. 9 hydrogens, 9 similar hydrogen atoms, and they would give singlet because the adjacent carbon atom has 0 hydrogens. Okay, so now we have 1, 2, 3, 4, 5 carbon atoms and 3, 3, 3, 9 hydrogens. So still we have to add 3 more hydrogen atoms, right? So these are 9 hydrogen atoms, 3, 3, 3, 9. And now this peak, these are 2 hydrogen atoms which also giving a singlet. So that means this would be a CH2, 2 hydrogen atoms, 9. Now we have total 11 hydrogen atoms, and now the last one would be an OH. So this would be the peak due to OH. And if you look at this structure, these 2 hydrogen atoms will also give a singlet, because they are attached to this carbon atom which has 0 hydrogens. Okay, and these three, 3 and 3, 9 hydrogen atoms, they would also give a singlet. This will be the structure, right? So all this information which they have given us in this question, it would be used to draw the structure. Okay,